Here are the ingredients you'll need to make your own mini temporary lava lamp. You'll have a jar of water, food coloring, you can choose red if you want to make it look like the lava, a container to put your water in, and oil. So you can fill your container up halfway. Okay, so you can add approximately 10 drops of food coloring. It's dark enough to be able to see the contrast between the vegetable drops and the water that you're going to form. Remember, the particle theory says that the particles in a liquid have freedom to move around in comparison to a solid. They're able to move around within the confinements of a container. Another property of water molecules is that they don't have a definite shape and will flow down to the bottom of the container. Notice how the water is mixing with the water, but as soon as I stop, all flows up to the container. And if you leave it for a little bit, all of the oil particles will start forming. Right now there's 4 big oil splotches, and it's going to congregate if they're close enough. So this is what the water molecule looks like, and note that the oxygen is exhibiting a negative charge. The charge is stronger than the ones for the hydrogen, so that makes the whole molecule negative, and that means that it's polar. And this is what a lipid chain looks like. Lipid chains and oil are insoluble in water because it's a non-polar charge, and they are hydrophobic, which means that they don't mix in with the water. So another reason why oil and water doesn't mix is because oil has a lighter density than the water does. Oil is approximately 0.8 grams per milliliter depending on what type of oil you use. I'm just using olive oil. Water's density is 1 gram per milliliter, and because it's heavier, then the water sits at the bottom and the oil is staying afloat. Now, the reason why I call this a temporary lava experiment is because once the salt has melted, the oil particle floats back up. So it goes down, the salt stays at the bottom, but the oil floats back to the top. Let's see.